Hello, today we are going to start talking about the language constructs of SPARQL. So the basic idea of SPARQL really depends on a very simple understanding. The understanding is that in your query, whenever you are specifying your query, you will be specifying a set of patterns, right? And these patterns are called graph patterns, and we have given a glimpses of different kinds of graph patterns in the introductory lecture for SPARQL. But this graph pattern is basically nothing but again a set of triples. So we are following the same old idea that whatever you represent in semantic web is basically a set of triples, right? See, here also we'll be representing this graph patterns as a set of triples. And this is, I think, what you are seeing here is the simplest graph pattern, basically a triple. So a subject, predicate, and object, a single triple, right? And out of these triples, at least one of them should be a variable. At least one of them should be a variable. Or all of them can be variables, but at least one of them should be variable. So for example, here you are representing something like I want to retrieve something which is our V. So this V is a variable, and this variable has got type to be actor, right? So this actor is a class, and this class is having as member or set a set of, this is a kind of a set, and this set has as members a set of instances, a number of instances, right? And what would be the number of instances? The number of instances would be obtained by replacing this V. So what we will be doing? We are replacing this V with one instance and another, right? So for example, we first instantiate this V with I1 and check whether I1 type actor is there in the knowledge base or not. So for example, if we take say uh, mm, Amitabh Bachchan, so I to be Amitabh Bachchan, so in that case that triple will be there in my knowledge base. So I Amitabh Bachchan will be retrieved as the answer to this graph pattern. But if you take say another instantiation like I2 say Albert Einstein, so Albert Einstein, so in that case you will not be finding any triple uh, that says that Albert Einstein is a type of active, right? So in that case I2 is not an instance that will uh, mm, that will help this pattern to be matched against your knowledge base. But on the other hand, I1, which is Amitabh Bachchan, would be one instance of our interest, right? So what we are doing here, while we are trying to move this pattern to check whether this pattern is matching is any part of the entire RDF database or graph, we're trying to bind this V. So this is what we call as binding. We are trying to bind V. We are trying to bind V with instances, with concrete instances like Amitabh Bachchan, Albert Einstein, so on and so forth. And for some of the instances, this pattern will be matching, but for the other set of instances, the pattern will not be matching. So for the set of instances which will help the pattern to be matched against the RDF database, those will be retrieved as our answers to the query. So this is the particular idea behind SPARQL, right? And depending on your requirement, the nature of pattern will be varied. So the entire set of language constructs, they talk about different kinds of information requirement, how this information requirement can be modeled using the constructs of SPARQL language, right? So to make it more concrete, let us take a real graph from DBpedia. So this is a real graph from DBpedia, and in DBpedia we have something like this. Christian Bale is an instance or RDF type of actor. Al Pacino is a type of actor, and Fighter is a movie, though we have not specifically mentioned here, uh, uh, which is starring Christian Bale, right? Now you have got the same query, right? So V is an instance of actor. So what we'll be doing? We'll be taking this pattern and trying to match against this, right? So let us take this to be the triple against which we are matching this triple graph, right? So we can see we have a match here, right? So we can take Christian Bale as our output or binding of the variable V, right? So we try it out with the other triple that we have in the graph. For example, this we have a match here. So we output Al Pacino, right? So we get another result. But there is another triple here, like the Fighter starring Christian Bale. So if we try to match this pattern with this is not a match. So we will not be having the Fighter, which is another entity in this database. It will not be our answer or binding to V. So this is the core idea behind SPARQL. To start with, let us have a very simple query. This query, anatomy of this query we'll be talking about in the next slide, but let us have a very quick look. So we are trying to model the same thing here. So let me run this query in DBpedia and then maybe try to analyze the anatomy of the query. So I'll be shifting to the DBpedia. Okay. Uh, So I have put down all the queries in a single document so that we can copy it from here and paste it in the DBpedia SPARQL endpoint. So we copy it. So this is the DBpedia SPARQL endpoint. So here you have a text box. You put the value here, right? And you can see that there are many ways to get the result or receive the results. So you can get the result in HTML format, you can get the result in JSON format, you can get the result in XML format. But for the sake of visibility, let us start seeing the result in HTML form, right? So if you just say go with the browse result option, we'll see that there are different actors like Al Pacino. 1979, it has also come as an actor. Might be it is kind of error in the database, but you can see other entries in the database like Antonio Banderas, so other names as actors, right? Now, what you can see that these results, they are kind of URIs, right? So they are having specific URL. You can see the URL in the box, right? So if you just click on any entity here, so for example Al Pacino, so you'll see the URL here, http dbpedia.org resources ai underscore Al Pacino. Let us copy it and paste it in the result box, sorry, URL box. So we see that Al Pacino is there and our specific relation. So, and you see that it is a structured data. Uh, mm, so you see that the abstract of Al Pacino, then birth name, birthplace. So all the details about Al Pacino is present here in the structured form. So the information that is important to us is RDF type, and for RDF type you can see that there is something called umble RC actor here. So that's why you are getting that as our result in DBpedia, right? So let us move back to the DBpedia SPARQL endpoint. Okay, yeah. Uh, So coming back to this presentation. Okay. Now let us with this let us look at the anatomy of a SPARQL query. Right. So what we have in a SPARQL query. So in the first place, you can have a set of prefix definitions, right? So this prefix definitions are basically the namespace definitions, right? So we know that namespaces are very useful in shortening the documents, RDF documents, right? We can replace these namespaces with the actual URLs. But if you don't choose to do that, this prefix declaration box will be optional, right? In that case, you don't really require this prefix definition. So that's why this is optional, right? Now you can see this is followed by something called select, right? So this is the query result clause, right? So what kind of result you want to see, right? So you can have select, you can have say ask, you can have say construct, you can have say update, so and so forth, right? Now, along with the select, you have a set of variables which you want as your output, right? So, for example, in the query last query you have seen, there we have tried to see the instances, the actor name or actor URL or URI who is a type of actor, right? Now this declaration will be followed by a from declaration. So this from declaration says so whatever you will be seeing inside this angular brackets, they are URIs, right? So this says that this is a URI of one RDF database. So this is a URI or location of RDF database. So here I'm trying to say that I'm querying from these RDF database. So whatever will be putting here, you'll be querying from there, right? Now you can have something called from named, then followed by one URI. So this is also a case of referring to one RDF database which you are trying to query using this query SPARQL query. But there is a subtle distinction. The distinction I'll not discuss about in this class. Maybe in subsequent lecture I'll try to demonstrate it with some example, the difference between from and from nodes, right? Now you see these two are optional. Why? Because we have just seen while we were querying a DBpedia, we did not have any from or from named, right? So this is not required, this from and from name not required if you are directly querying one SPARQL endpoint. So this DBpedia where we're putting our query, that is a SPARQL endpoint, and as we are putting our query there, it is imperative to say that we are trying to get an answer from that database. So that's why this from and from named is not really required, right? So that's why they are optional. But this where clause is mandatory. So this where clause contains the graph patterns, right, or the triple patterns. So this is the kind of core of a SPARQL query. All your requirements have to be specified here, right? So that's why it is mandatory. And we'll see different kind of patterns. We'll be playing with different kind of patterns, right? Now it will be followed by a set of constructs that are again optional, like order by. So for example, you want to order the result by some value. So for example, you have extracted the country and their population size, and you want to order the countries by the descending order and by the order of the population size, right? So there you need order by, but if you don't want to order it, it is not really required, right? Now then comes limit and offset. Now with limit, you can say that I want only say 1,000 documents or 1,000 results, right? Now what offset will do? Offset will say, okay, you give me some results starting from say 100th result, right, or 150th result. So these limit and offset, they will be required when you want to query the database and the result that you are getting, the set of results that you are getting, that is huge. So for example, you put forward a query that is having say 50,000 records as answers. So you cannot really transfer 50,000 records at a single go. That will be too risky. Maybe your connection will not persist during the entire time. So in that case, what you can do, you can say that, well, I start with offset 0 and then get me say first thousand records, and then in the next set you start with 1000 offset and then get the next 1000. So you can use a combination of this limit and offset to get the records in a very piecemeal manner, right? So as far as the graph patterns are concerned, so they are expressed inside the where clause. So inside the where clause, we represent these graph patterns, and as I have mentioned, these graph patterns can be basic graph patterns, and if you group different basic graph patterns, this basic graph pattern is basically a triple, right? And if you group them together, this will become a group graph pattern. And you have something called optional graph pattern. I'll take each of them and try to illustrate with some example queries. And finally, you have got union graph pattern, graph pattern, and constraint. So you can have these things inside a where clause, right? Now this can be you may not have all the things together in a single where clause. Depending on what kind of information you need, you want to pick up the graph pattern that suits the information need best. So this is the first query we will like to start with as far as the basic graph pattern is concerned. So as I mentioned, basic graph pattern is basically a combination of SPO, a basic triple, and here we are trying to extract the cricketer who has got hometown in Ranchi. So this query I'll be running with ARQ. So we'll be using the command prompt to execute this query, and the data about this query. So this ex002.ttl, it is a turtle file. It contains information about all or not all information about the Indian cricket team members, and this query is written in ex001.rq, the same thing you can see here, right? So here we are, the variable is the cricketer, and these are the concrete things, and we like to find instance of this variable cricketer for which this triple becomes true as far as this knowledge graph is concerned, right? So I'm not opening these files. I'll share the files with you. You can open and see what is there, but I like to execute the query. So I'm going to the command prompt. So the structure of the command is you want to run this sparql.bat. So this is for Windows, but for Linux you have got similar facilities. This is how you can specify your query. And as we know that the query is written in ex001.rq and the data is residing in ex002.ttl. Now if you execute this query, you will get an answer at one URI, right? So because this triple you have seen, uh, mm, okay. So here you can see that the variable is appearing in the subject position, and by definition the subject position will always have one URI. So the result will always be one URI, right? Also, you can have multiple entries in your as basic graph pattern. So you are having two different triples. So this is a real query that can be executed in DBpedia. And here we are trying to say that give me the Indian Test cricketer whose birthplace is Ranchi, right? So this is the similar query we are running. Let us try to run this query in DBpedia. So we are going back to DBpedia endpoint. We know we have already represented our query here. We paste the query here. If you say go, you can see the result is coming out to be Mahendra Singh Dhoni, again one URL, right? Okay. Uh, so you can have multiple triples. So this is an example where we are trying to see that we can use the same old turtle format to represent the query if you have got many basic graph patterns. For example, we are trying to here say that the name of the movie and the actors of those movies that are distributed by Warner Brother, right? So this movie is the variable, and actor is the variable, and this movie name is the variable, actor name is the variable, right? So this actor name, they are, as you see that they are connected via RDFS level, so they will be kind of string representation of the movie, right? And this actor name will be the string representation of the movie. Now, if you can quickly execute this query in DBpedia, let us see the difference between URI and the literal value of the entities, right? So we have our third query. Okay. So you can see the results that are coming. Okay. So these are string representation of the result. No longer we are getting the URI, right? So, but one thing you can see that Clint Eastwood is coming with space cowboys with multiple times. So this is overwhelming, and this Clint Eastwood is represented using different forms like in Arabic, in Japanese, in Chinese, in English, in other languages, right? So what we are interested in, to get the result of for only English title and only English movie names. So let us see how to do that. So for that, we'll be using something called a filter, right? So this part of the query remains to be the same, right? So you can see that this part remains the same, but we are adding something called filter, right? And I'll talk about the filter while we go back to the slide, but let us first execute this query. So we are trying to retrieve all the English titles and movie titles and actor titles, and for those movies that are distributed by the Warner Brother, right? So you can see the most of the clutter is gone. You can see that Clint Eastwood is coming only once with Space Cowboys with English as both actor name and movie name, right? And that is similar with other entries here as well. So let us go back to the format of filter, right? So how does a filter look like? The filter look like, so filter starts with a filter command. So this is a reserved keyword, and inside the filter you can use functions, right? So we are using a lang function, and lang represents language, so we are using language function, right? And as argument it is taking or accepting one variable, and a filter will always contain at least one variable, right? It can involve multiple variables, but it should contain at least one variable. Now what this will return, it will return the tag of this particular string, and if it is equal to n, then you put that result in the result stream, otherwise, or output stream, otherwise you discard that or the other part. So if it is not equal to en, you discard that, and that goes same with the movie name, right? So you can also do something else. So you can use standard vocabulary. So one standard vocabulary we know is friend of a friend. So we are making use of it here along with the DBpedia kind of namespaces. We are using FOF namespaces or FOF vocabulary, right? So here in this query, we are trying to find out the movie name and the female actor name, and for those movies that are distributed by Warner Brothers. So we are trying to filter more, right? So these part of the query will remain the same, but we are adding one more filter, and here we are using something called regex. So we are using regular expression, right? So regular expression works on strings. Now you know that this gender has a string value, right? Now this gender can be written like male or it can be female, right? So what we are saying here, that we could have written like say gender equal to say female, as we had written earlier, like say language movie name equal to en. So here doing the same thing using regular expression. But the point that is that where this it is getting different from this is that this is not an exact match. So for the sake of argument, let us say we have just written say FEM, right? So then also if you have the value of gender or the instantiation or binding of gender to be say female, there would have been a match between these two, right? Which would not have been possible with this equality function, right? And also in equality function, it will not also be possible to check whether if you have in gender like you have say female, F is capitalized, and here in the pattern you have say female. So it is not going to match. So this is not going to match, right? So you have another way to say that you ignore the case. So this is called case sensitive or not. So the third argument here is case sensitive or not, right? So it can do an approximate match over the input string, right? And here you can also write some patterns. So for example, if this contains a digit, so say it starts with say 1, say 0 to n, right? Or alphabet, say A to Z, right? So all these patterns you can specify here to match with the value that we are having on the variables, and depending on that whether you have a match, you put the result in the output stream, right? uh, Now the next important thing after the basic graph pattern is an optional graph pattern. So what do we do in optional graph pattern? As we have mentioned earlier, that there are certain things or certain patterns you want your query to always match, right? So for example, here we are trying to list or retrieve the list of companies. I'll say software companies. I want to list down all the software companies. So how do we do that? We say that X is a type of company and the industry of X is software, and here we are getting the string name of the company. So this is the baseline. So this is what I want always, but I'll be happy, and that we want to do for the only English titles, right? So I'm not interested in the company which is having non-English name maybe, right? So this is what I always want. And the next thing what we are saying, that TVpedia founder has founder to be founder, sorry, this X has got founder to be founder, has got product to be product, and has got date to be foundation date. And this is also what I want. These two I want. And let us see if we put this query, what will happen, right? So, okay, let us go back to DBpedia. Okay, so So this is also considering the basic graph pattern, right? This is also considering the basic graph pattern. So we'll replace this query. Yeah. So what you can get as result, that the results are the companies that are having the founder value, the foundation day value, and the product value, but it is not having any entry which are having any of these other fields to be missing, right? So let's say I change my requirement. Okay, I want the companies that are working in the software industry, but if the founder, foundation day, and product, if it is not there, I'm okay. You give me the list name of the software company, but for the software company for which these three information are there, you give that to me, right? So for that, we take this block, this particular block, and put this under the optional block, right? So this is exactly what we are doing here. We are putting that in the optional block. So let me first run this query, and then we'll go back to the slide and to analyze it. Okay. Uh, so what you can see here as a result, that there are two types of companies. So the first set you can see from starting from Symbolics to Google. So all of them, they are having the company name, founder, foundation day, and product, right? But there is a second category starting from Signal Solution and the others. They are having only name are blank in the other categories, other columns, right? Because we have made it to be these other three to be optional, right? Now let us get back to the slide and try to analyze what is happening, right? So here we have put this particular fragment, inside the optional block. So this is our new keyword. So this we have put inside the optional block. So this part is matching. Whenever this part is matching, this is coming as output, irrespective of whether this part is getting matched or not. So if this part is getting a match, then we retrieve this founder, product, and foundation day. So that's why this is called optional, right? Now think of a scenario like this. So you have taken out this foundation day from this place to this place inside another optional block. We have created another optional block, right? So can you guess what will happen? So let us try to execute the query and then try to analyze, right? Okay, so this is the improvised query. So we will not uh, tell what is going to be the answer. So as we get the answer, then we will try to analyze this. Why did that happen? So if we say go, now you can see there is a first category for whom you have got all the information. So starting from symbolics to this part. So the part that I am highlighting, they are having all the information. Now this next part, starting from IQMS and Microsoft and so on and so forth. So you see, you have got the company name, founder name, product name, but not the foundation date, right? So this is because these companies, they are having a match here, they are having a match here but they do not have a match for the foundation day. They do not have the entry for foundation day. So that's why this part is getting blank, but they are getting listed here. Now coming to the third category. In the third category, the companies, they do not have the founder name and the product name, but they have the foundation name, right? So for this query, this part is matching, this part is not matching, this first optional part is not matching, but the third optional part is matching, right? Now coming to the fourth category. For the fourth category, you do not have any of these optional category blocks are matching. So this part is matching, the mandatory part is matching, but none of these optional blocks are being matched here, right? So that's how you need to analyze the meaning of the optional block, right? So let us look at another interesting feature of this optional block. We can do something else. So let's say you have the company. So this company, they have got their entries in DBpedia. Let's say you have company C1. You have three companies, C1. And for C1, you have one relation, say key person, right? To be say K1, right? And there is another company C2 who have founder to be say F1, right? And let us consider that there is another company C3 which has got both the entries, like say key person and say founder, right? And let us say this is say K2 and F2, right? Now let us try to see what we have written here. So the first part is simple, what we are doing here, doing for the last few slides. Now the next other two optional parts are important. So in the first optional part, we are saying that X key person CEO, right? So if we say that, so for this particular case, this K1 will be instantiated against CEO, right? Now for this particular case, what will happen? Now we don't have any key person, right? So this part will not be invoked. So this optional part will be invoked for C2. And in this case, F1 will be instantiated against CEO for C2. So in our output, we will be having C1, K1, right? C2, F2. Now coming to the third case. Now in the third case, we have got both present, right? So as it is optional, is it like both K2 and F2 will be our result? So that is not exactly so. So this is one very detailed information about optional. So it will only match the first case. Even if you have the other case to be present, it will skip the other case. So what will happen? It will first check, as we have the key person in the first place. So if we have this key person here, then K2 will be instantiated here, and we will not have F2 instantiated. So F2 will not be instantiated, and the output for the case of C3 will be C3 K2, not F2, right? So here the query says that if the key person is available, then the person is CEO or the founder is CEO, right? So this will be the expected result. Let us try to run this query in reality. So I think, yeah, this is the query. So I'm replacing the query. Okay. Now, if you run this, first entry we have got Microsoft. Let us try to see the Microsoft page for in DBpedia. We have got founders also, right? So in the here we have got both Bill Gates in both the places. So this is not a good case to consider, right? So let us check another. Mm, uh, should we look at Google? So yeah, so we have got Sundar Pichai, right? So let us go to the Google page in DBpedia. Go, then DBpedia intercondition, right? And Seco. So what you see, the companies and the bosses, right? And I guess we'll be having entries where the companies which do not have bosses, right? Mix of both, right? And from this, I want to exclude this set where we have got these boss names, right? So for that, I'll just take this part, this filter bound boss, and put it here. We are imposing the filter again. And if you do that, you can see that the companies that do not have boss, they have been put in the output stream, right? Okay. So far so good. The same thing you can do by saying that not exists. So the triples where the companies or the entries where you do not have these triples. So we just say not exists. You can also say that this is a set which is basically mix of all. So these are all software companies, and this set is basically a set having bosses. So set having bosses, right? So what you do, you take as minus. So you do a minus between two sets, and whatever is remaining, that will be your output. So you got three ways to say the same thing. The software companies that do not have data about key person in DBpedia. So with this, let us stop today. In the next lecture, we'll start talking about the union graph pattern. Thank you very much.